This is the second part of a Level 2 Functional Skills Maths paper from NCFE. In this part, you can use a calculator. Activity 2, running a business. Dan has set up a patio cleaning business. He charges £4.25 per square metre of the patio to be cleaned. Mrs. Jones has asked Dan how much he will charge for cleaning her patio. This diagram shows the patio. How much will Dan charge Mrs. Jones for cleaning her patio? Use pi equals 3.14. So we've got this rectangular area which we can work out the area of quite easily. So go 9.25 times 3.3, which gives us 30.525. And now we've got to work out the area of this part of the circle. As you can see, it's a quarter of a circle. So we'll go pi r squared divided by 4 to get a quarter. So pi is given to us as 3.14 and radius is 3.5. And we've got to square it. Then all of this divided by 4. So plugging it into the calculator, we get 9.61625. So adding them two together, gives us 40.14125. Let's multiply this by how much he charges, which is £4.25. Which gives us 170.6003125. Now, as we're talking about money, we're going to round this to two decimal places, so it's £170 and 60 pence. Mr. Patel pays down £250 to clean his patio. The £250 includes VAT at 20%. How much was the bill before the VAT was added? So let's represent the 100% amount before VAT is added via this bar. So that is 100%. Now we've added the 20% as well to this. So this whole amount is equal to £250. We're looking to work out the 100% amount, so without the 20% added. So what we're going to do is 250 divided by 120, because that's how many percent that represents. And that's going to give us the 1% amount. And this gives us 2.0833 and so on. So 3 is recurring. We're going to multiply this by 100 now, so it gives us the 100% amount, which is what we are after. So 2.0833 times 100 is going to give us 208.33, rounding it to two decimal places. Dan needs to make a mixture of weed killer and water to clean Mr. Patel's patio. The area of the patio to be sprayed is 63.2 square meters. He fills the spray tank with the weed killer and water mixture. How many times does Dan need to fill the spray tank to cover the whole patio? So here is the area, 63.2. We've got here the instructions which say use 20 milliliters per square meter of patio. So we're going to multiply 63.2 by 20. Which gives us 1,264 milliliters. If we divide this by 1,000, it's going to give us 1.264 liters. So we've converted it to liters. Since the capacity of the tank is given in liters. Now it says that we need to mix weed killer to water in the ratio of 1 to 10. So we're going to need 10 times more water. So multiplying 1.264 by 10, we get 12.64 liters of water. So adding these two together, the two amounts, water and the weed killer, we have 1.264. Gives us 13.904 liters of mixture. The capacity is 5 liters, capacity of the tank. So how many 5 liters would fit into this? So that would be 13.904 divided by 5 gives us 2.7808. So that is 3 times. Dan wants to expand his business. Next year he plans to clean patios from 8:30 a.m. to 3:30 p.m. Monday to Friday for 26 weeks during the spring and summer. This table shows how long each job took Dan this year. The times include travel time. Use the data to estimate how many patios Dan can clean next year if he works the hours planned. So first we're going to estimate the time it takes to do one job. So we've got a range of values, time between 30 and 60, that means 45 is the midpoint, which then we're going to multiply by 25. So between 60 and 90, we'd have 75. Between 90 and 120, we'd have 105. Between 120 and 150, we have 135. And adding all of these together gives us 11,385. Now we're going to divide this by 127 jobs that were done in total. And this gives us 89.2 6, 4, 5, 6, and so on. So this would be minutes, which if we divide by 60, it's going to give us the number of hours. Which is about 1.49 hours for one job. So now we'll estimate the total number of jobs he can do in the year. So he plans to clean patios from 8:30 to 3:30 p.m, which is 7 hours, and Monday to Friday, so that is 5 days, and that is for 26 weeks. So if we multiply 7 by 5 by 26, should give us the total number of hours. So 910 hours he plans to work for the whole year. So now, if one job takes 1.49 hours, how many jobs can it fit in 910 hours? So 910 divided by 1.49, or you could have divided by 1.5 in here. So 910 divided by 1.49 gives us 610.738255. So we can round it up to 611 or go to 610 because he wouldn't finish the last job basically. So 610 patios, I'm going to say. This table shows how long a job took done last year. Dan's accounts are checked by the tax office. They pick one of last year's jobs at random to check. What is the probability that the job would have taken more than 90 minutes? So more than 90 minutes, it would be this range here and this one here. So that is 30 jobs and 16. That is 46 out of the 82. So 46 divided by 82 gives us 0.56097 and so on. So that means in terms of percentage, it's going to be 56.097 and so on, and I'm going to keep it at 56%, rounding it to the nearest whole number. There are 51 million adults in the UK. 20.5 million do not do any regular exercise. What fraction of adults in the UK do not do any regular exercise? So that is 20.5 out of 51. But we know that we can't have a decimal in a fraction, so I'm going to double it. 20.5 and 20.5 gives us 41. And then again, 51 doubled gives us 102. And that is our fraction. The proportion of commuters who cycle to work in the UK is 0.06. Write 0.06 as a fraction, a percentage. As a percentage, that is quite straightforward. So 0.06 is, if you had a pound sign in front, that would be 6 pence, and that's how many percent that is, so 6%. In terms of fraction, we know that it's 6%. So 6 out of 100, in other words. And we can leave it here as 6 hundredths. Jackie is training for a cycle race. She reads a cycling blog. It says that cyclists should aim to keep their heart rate above 72% of the maximum heart rate. Jackie uses this formula to work out her maximum heart rate, which is M is equal to 191.5 take away 0.007 times A squared, where M is the maximum heart rate in beats per minute, A is age in years. Jackie is 25 years old. This scatter diagram shows the relationship between power in watts and heart rate beats per minute. To produce 100 watts of power, a cyclist uses about 350 kilocalories per hour. Estimate the number of kilocalories Jackie uses per hour if she cycles at 72% of her maximum heart rate. So let's work out her maximum heart rate first. And got M is equal to 191.5, take away 0.007 times age, which is 25, squared. So this is 191.5, take away 0.007 times 25 squared is 625. So we'll do now multiplication before we do subtraction. So 191.5 take away 0.007 times 625 gives us 4.375. And this gives us 187.125. So this is Jackie's maximum heart rate, 187.125. We've got to work out 72% of the maximum heart rate. So we're going to go 72 divided by 100 times 187.125, which gives us 134.73. So that's roughly about 135. Now going back to the question is estimate the number of kilocalories Jackie uses per hour if she cycles at 72% of her maximum heart rate. So looking at the scatter diagram, so we'll need a line of best fit to help us estimate. Trying to keep an equal distance between the dots on both sides. So estimating this when the heart rate is about 135. So let's go to heart rate 135. This would be 130. So about here is 135. This gives us 160 watts. So to produce 100 watts of power, a cyclist uses about 350 kilocalories per hour. So we've got to estimate the number of kilocalories that Jackie uses per hour if she cycles at 72% of her maximum heart rate. And we estimated the number of watts of power when she cycles at 72% of her maximum heart rate, and that was 160. Now we'll need to get the number of kilocalories. So these go in direct proportion. To get from 100 to 160, we multiply by 1.6. In other words, 160 divided by 100 gives us 1.6. So we'll do this on the other side as well. 350 times 1.6 gives us 560 kilocalories. Rafa and his friends cycle to keep fit. They want to reduce the mean time it takes them to cycle 10 kilometers. Their target is to reduce the time by 11% within 12 weeks. This table shows their times in week 1 and week 12. Has the group achieved its target? Show how you decide. So we'll work out the mean for both weeks and see whether the reduction from week 1 to week 12 is equal to 11%. So adding all the minutes within week 1 gives us 161.7, and adding all the minutes for week 12 gives us 146.3. So now dividing 161.7 by 7, because there are 7 people, we get 23.1. Dividing 146.3 by 7 gives us 20.9. So this shows that there's been a reduction, but we need to work out what percentage that is. So 23.1 take away 20.9 gives us 2.2. So 2.2 out of the original value, the week 1 value, which is 23.1. Doing it using a calculator, 2.2 divided by 23.1 gives us 0.0952 and so on. So in terms of a percentage, this is going to be 9.52%. So comparing this to the 11% that was their target, has the group achieved its target? No, they haven't. Peter cycles around this route. She starts at A. When she reaches B, she has cycled 12.5 miles. What is 12.5 miles in kilometers? Use this conversion. 1.6 kilometers is equal to 1 mile. So if 1 mile is equal to 1.6 kilometers, 12.5 miles will be 1.6 times 12.5, which is 20 kilometers. The total route is 23 kilometers. What fraction of the total route has she cycled when she reaches point B? Should have done 20 out of 23. So 20 23rds. Activity 4, packaging. Beth is on a work placement. The company makes biscuits. In 2018, it reduced the number of biscuits in each packet. The weight of each biscuit stayed the same. The weight of a packet went from 135 grams to 108 grams. The 135-gram packet contained 25 biscuits. How many fewer biscuits did the 108-gram packet contain? So as the weight of the biscuits hasn't changed, I'm going to do 135 divided by 25 to work out the weight of each biscuit, which is 5.4 grams. So now I know the weight, so what I'm going to do is 108 divided by 5.4 to work out how many biscuits there are in 108-gram packets, which gives us 20. So 20 biscuits in the 108-gram packet. And there were 25 in the 135-gram packet. So 25 take away 20, that is 5 biscuits fewer. The company also makes pizza. This table shows information about the two sizes it sells. We've got large and small. Beth says the large size gives over 5 times as much pizza as a small size. Is Beth correct? Show how you decide. Use pi equals 3.14. So we're going to work out the volume of both of the sizes. So we get area and multiply it by depth. Area of a circle is worked out with the formula pi r squared. So for the large one, we'll go 3.14, which is pi, times the radius, which is 38 divided by 2, and that gives us 19 squared. And using a calculator, this gives us 1133.54 centimeters squared. If we multiply it by the depth, it's going to give us the volume. So 1133.54 times 2 gives us 2267.08 cubic centimeters. Let's repeat the process for the small pizza. So 3.14 times, now that is 19 centimeters diameter, so we're going to go 19 divided by 2 to get the radius, so that gives us 9.5. We're going to have to square it, and this is 283.385 centimeters squared. To get the volume, we're going to need to multiply this by 1.5. And it gives us 425.0775 cubic centimeters. Now, Beth said that the large size gives over 5 times as much pizza, so we can divide this by 5 to see if this is more than 425.0775, or multiply 425.0775 by 5 to see if this is smaller than 2267.08. I'm going to multiply 4 to 5.0775 0.0775 by 5, and it gives us 2125.3875 cubic centimeters. And the volume of the large pizza is actually larger than that, is higher than that. So Beth is correct. The large pizzas are sold in cardboard boxes. When closed, the boxes measure 40 centimeters by 40 centimeters by 2.5 centimeters and are cuboid. This is the net of the pizza box. The company thinks it could use the same net but reduce the dimensions to 38 centimeters by 38 centimeters by 2 centimeters. Beth is asked to calculate the percentage reduction in cardboard if the smaller boxes are used. What answer should Beth get? So we're looking to calculate the percentage reduction in cardboard. That means we are going to calculate the surface area. So looking at the dimensions, the area of the yellow square is worked out by going 40 times 40, which gives us 1,600. And that's repeated here as well, because we have an identical square. And what we also have is the flaps, the sides and flaps. So all of them have a width of 2.5 centimeters. So this width here is 2.5 centimeters and the length is 40. Same over here, length 40, width 2.5 here as well. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them that are identical. So 2.5 times 40 times 9. Because there are 9 of them. And this is 900. Also, we had 1,600 and 1,600. Which gives us 4,100. Now let's look at the new dimensions. Got 38 by 38 by 2 centimeters. So we're going to replace the 40 by 38 and the 2.5 by 2. So we're going to do, for the squares, we're going to do 38 times 38, and it's 2 of them, and that is 2,888. And in terms of the flaps, we multiply 38 by 2, and it's 9 of them, so we're going to multiply it by 9 as well, and that gives us 684. Adding them two together gives us 3,572 centimeters squared. So we've got a reduction in size, and we're going to work it out. So 4,100, take away 3,572, gives us 528. And this is 528 out of the original surface area, which was 4,100. And using a calculator to go 528 divided by 4,100 gives us 0.12878 and so on. To get this as a percentage, we multiply it by 100 or move the decimal point 2 places to the right. So then we get 12.88% rounded to 2 decimal places. And that answers the question. The company also makes a chocolate bar. It's divided into 10 identical triangle-shaped pieces. Draw a plan view of the bar in the space below. Label the dimensions. So a plan view means looking at the shape from above. So when we look at it from above, it's going to look something like this. The line in the middle, then we have 10 rows. So we'll draw it here. Should be 10 rows as we said earlier. So I'm going to add another 2. And we're going to label these, the dimensions. So this is equal to 10 centimeters. This is equal to 6 centimeters. This is equal to 3 centimeters. And finally, one of these is equal to 1 centimeter. One triangular face of the chocolate bar is shown in the diagram. Calculate the size of the angle labeled A. So we've got a triangle and we know that all the angles inside the triangle will add up to 180. We've got 50 and 50 already, so adding them up gives us 100. 180, take away 100, leaves us with 80 degrees. So angle A is equal to 80 degrees. And this is the end of the paper.